Hello and welcome back to Gaffy's Grinds. This is video 3 in our series on particles. Today we're going to be looking at changes of state. So we're going to take this topic, break it down, try and help you understand it real simply, and then do some practice. Quick reminder to stop you from getting distracted. Let's take your phone out and either turn it off or put it in a different room where it can't buzz and distract you. Close any other tabs you have open, and most importantly, I'm going to ask you to do some tasks and questions, and when I do, you should stop the video when I ask and do them. Otherwise, if you don't do them, unfortunately, I cannot make you do them, but if you don't, you're not going to learn as much, and to be honest, you're just wasting your time doing these videos. Okay, a reminder then that in our previous video, we looked at the 3 states of matter. So on 3, I want you to speak to your screen and name the 3 states of matter. So 1, 2, 3. Okay, I'm hoping you said solid, liquid, and gas. This is the 3 states here at the moment. Now, all substances can exist in the 3 states of matter, solids, liquids, and gases. And changing between these states is a physical reaction, okay? It is not a chemical reaction. No new substance is made. The particles stay the exact same. There's exact same particles of the same substance. It might not look like these in my diagrams here, but the particles are the exact same. I know they might not look exactly the same size, but they are technically the same size. We're not squashing them, we're not making them bigger, and we're not changing them in any way. So the particles are the exact same. So it is a physical reaction or a physical change, not a chemical change. Okay, so we're going to look at some of the changes of state. What is a change of state? It basically means matter or substance is going from one state to another state. So, for example, from a solid to a liquid. So, when a substance goes from a solid to a liquid, and we can show this using an arrow like this. Okay, so from a solid to a liquid, this is what we call melting. So we call this melting. Now, what about when a liquid goes back to a solid? We call this freezing. A liquid goes back to a solid. Those two are pretty easy, and we should be pretty familiar with those from our everyday lives. A liquid going to a gas is called evaporation or boiling. Evaporation or boiling. Evaporation can take place at any temperature between the melting point and the boiling point of a substance. So if we take water as an example, water's melting point is 0 degrees. It turns into a liquid at 0 degrees. Its boiling point is 100 degrees Celsius. Evaporation will take place at all temperatures between 0 and 100, but it happens to be quite slow. Boiling takes place only at one temperature. It is a much quicker version of evaporation, and the boiling point of water is 100 degrees. So at exactly 100, the water will boil. It will evaporate at 70, at 50, at 40. This is why puddles, after it rains on the ground outside, the water evaporates and could be gone in the afternoon. So if it rains in the morning, puddle, afternoon, it's gone. So what's happened to it? Well, it has evaporated. It's not boiling because it's not 100 degrees, but it is evaporating. The most difficult one to remember, I think, is from a gas back to a liquid. So say you boil the kettle and you've got steam coming out of the kettle and it hits a cold surface like the tiles in your kitchen. You will see little droplets of water forming where the steam is turning back to a liquid. We call this condensing. Condensing. There is one more interesting one, and that is when a solid does not turn into a liquid, but turns directly into a gas. Only some substances do this. An example of this would be dry ice, which is frozen carbon dioxide, solid carbon dioxide, which does not turn into a liquid, it turns directly into a gas. We call this sublimation. Okay, it's question time. let's ask some questions that I want you guys, how do I want you answered? I want you to speak them out to the screen on 3. Okay, so the first question is, what do these circles in these diagrams represent? On 3, 1, 2, 3. Okay, I'm hoping that you said they represent particles. So each circle represents particles. Okay. Now, second question. Changes of state. Are they an example of a physical change or a chemical change? On 3, 1, 2, 3. Changes of state are examples of physical changes. There is no new substance made during this process. Okay, good. We're ready to move on, discuss the next bit. Okay, so the question is, if we take any particular substance and we're going to look at it as a solid, as a liquid, and as a gas, what are the kind of differences between the substance when it's a solid and a liquid and a gas? We're not talking really about its properties, but what's causing it to be a solid, a liquid, a gas? Okay, so I want us to consider temperature. Okay, so if we take a particular substance, let's think about, for example, water. Okay, water is a substance we're all familiar with. Well, water, when it's frozen, what is it called? Well, it's called ice. Water, when it's a liquid, we just call water, but I suppose technically liquid water. And water as a gas, we would call water vapor or steam. Now, in terms of temperature, where is it highest and where is it lowest? Okay, well, generally, when we're talking about the solid of a particular substance, this will be where the substance is at its lowest temperatures. Oh, excuse me. Lowest temperature. And when we're talking about gas, we're talking about it at its highest temperature. So if we were to measure the temperatures, we would find that as we increase, make it go from a solid to a gas, we are increasing the temperature. Okay, now, how do we do this? How do we increase temperature? Well, again, if we're going this direction, left to right, we will be adding heat, or adding energy, adding energy or adding heat. Okay, we do this using an energy transfer called heating. Okay, now, when we're going the opposite direction, from a gas back to a liquid, we are removing energy. We call this cooling. Okay. Okay, it's your turn now. What I want you to do is on 3, I want you to pause the video. I want you to draw what you see here. So draw out the diagrams, label them solid, liquid, and gas. And then I want you to put the names of the process on each of the arrows. I will do one for you to show you what I mean. Okay, so I will do the hardest one, I suppose, and that is this one, sublimation. Sublimation. So basically, when we go from a solid to a gas, we call it sublimation. What do we call 4 other arrows? So pause the video and do that now. Okay, so you should only be now watching the video again if you have filled in the other arrows. Okay, a reminder then, you should have, this is what you should have. Okay, so solid to a liquid is melting. Liquid to a gas is evaporation or boiling. What is the difference between evaporation and boiling again? On 3, 1, 2, 3, speak your answer. Okay, I hope that you said evaporation takes place at any temperature between the melting and boiling point, but boiling takes place only at a specific temperature. You should then have gas to liquid is condensing, and liquid to solid is freezing. Okay, all right, well done if you had that. We're back to this diagram again. You should have this filled in up to now. Tell me about how to change from a solid to a liquid to a gas. What do we have to do? Okay, so what do we have to do to the substance to change it from a solid to a liquid to a gas? Okay, so pause the video and fill in some arrows. So I'm going to draw the arrows for you actually. Okay, so one arrow goes this way and one arrow goes that way. What are we doing on those arrows to change it between a solid, a liquid, and a gas? Pause the video and fill in the arrows. Okay, you should be watching the video if you've tried that now. This is adding heat. Adding heat. This is removing heat. Heat, sorry. So this is cooling. And this is heating. Well done if you got this right. This is heating. Now, the last thing I want to talk about is why does adding heat cause it to change from a solid to a liquid or to a gas? Well, when we talked about solids, for example, we said that there are strong forces of attraction holding the particles in a solid together. So if we have solid, say salt, sodium chloride, the particles that are holding the solid together are strong forces of attraction. So they are held together very tightly and they're not able to move very much. So if we want them to break apart, we have to overcome these forces of attraction. We have to add energy to the particles. When we add more and more energy, this allows the particles to move enough that they can just free from each other. They can just kind of overcome the forces of attraction, and it allows them to slip and slide past each other like they would in a liquid. So by adding more energy, you're allowing them to move slightly more, vibrate more, move more, and that allows them to start behaving like liquid particles. Keep adding more and more energy, well, eventually you will overcome the forces of attraction completely. And at that point, when the forces of attraction are completely overcome, the particles can then kind of do what they like. They can fly around, move around. They're not really attracted to each other at all. They have so much energy, they're moving about, and that's when what we call the gas particles, so they're behaving like a gas. Again, it's important to note what's in between the particles. Absolutely nothing, empty space. There's nothing in between the particles at all. Okay, and if we were to take one of these particles, say a gas particle, would it behave like the substance? So if we're talking about water, for example, would the single particle of water, would that look like water? Would it be runny? Like, would it look like water particles? No, it's just a single particle then. So water behaves like water when we've got a group of particles. A single particle flying around as a gas is actually nothing like liquid water. It doesn't have the same properties at all, only when there's loads of them together. Okay, anyway, okay, it's your turn to do some practice now. So question time. Okay, so you're going to pause the video and you're going to answer these 7 questions, and then the answers will appear after. Like, it's really important that you guys actually do pause this and try these questions now. Okay, so do that now. Pause the video. Okay, you should only be watching the video now if you've paused and tried to do them questions. All right, draw a particle diagram for a substance which is a solid. I'm going to show you that in a second. I hope you know how to do that. Draw a particle diagram for what the substance looks like when it is melting. Well, there's number 1. There's the particle diagram as a solid over here. That's the particle diagram as a solid. Draw it after it's melted. What's happened to it? Well, then you have to draw it as a liquid. So it's melted, it's become a liquid. And draw it after it evaporates or boils. Now we're drawing it as a gas. Okay, question 4. A liquid is cooled down. What could happen to it? It could freeze and turn into a solid. That's what could happen to it. Okay. A liquid is heated up. What could happen to it? Well, if you take a liquid, start as a liquid, heat it up, what could happen to it? Well, it could evaporate and turn into a gas, or you could say it could boil and turn into a gas. Number 6, the student says that when a liquid boils, the particles get bigger. The student is wrong. Explain why. Okay, hopefully you can spot the mistake there. It's basically that the student is wrong because the particles do not get bigger. They get more energy and the space between them gets bigger. The particles themselves don't change. They're still the exact same particles. And number 7, in terms of the properties, what are the main differences between solids, liquids, and gases? This is a quick revision question. Okay, solids cannot flow, but liquids and gases can. That's a big difference. Solids can't flow, liquids and gases can. So flowing is a property. Whether something can be compressed is a property. So solids and liquids cannot be compressed, but gases can be compressed. We saw that in the previous video. And solids have a fixed shape. That means a lump of iron will stay as like a block of iron, or square block, will stay as a square block. Okay. Uh, so we say it has a fixed shape, but liquids and gases, they'll just take the shape of whatever you put them into. So if you put water into a graduated cylinder, it takes the shape of a cylinder, tube. If you put it into a cup, it takes the shape of a cup. If you put it into a bowl, it takes the shape of the bowl. So it'll take the shape of whatever container you put it in. Same for gases. So they don't, so we say liquids and gases do not have a fixed shape. Okay, that's all for today's video. You have learned about the three states of matter and how we can change between solids, liquids, and gases. Okay, so I'll see you in the next one.